Hello, welcome back. This is the third MQL by request, and it's also part 3 of building the framework for the EA. So this will be the last part where we're just building the framework, and after this we'll move on to answering specific questions and using the framework to build experts. I thought before we get started on the final parts of the framework, I would just recap on where we are. So we started by building an expert advisor, and this is just a shell. The real work is done inside an expert object that we create. The expert advisor itself will create and delete that expert object when it's finished, and while running, the expert advisor will pass the events to the expert object. So if you look at the functions inside an expert advisor, there are things like onTick, onChart event. They are all event handlers, and the platform calls those event handlers when the specific events occur, and our expert advisor in this framework is simply then calling the event handler methods of the expert object. Strictly speaking, the onInit and onDinit are also events, but because they're called at the beginning and the end only, I'm considering them slightly differently, and they're only used in the creation and deletion of the expert object. We've also created an entry signal class. So the purpose of this class is to tell the expert object when to enter a trade and in which direction. The expert advisor then creates and assigns that entry signal object to the expert object, and also takes care of deleting the entry signal object when the expert advisor terminates. Then there's also the exit signal, which performs exactly the opposite function to the entry signal. It tells the expert object when to exit the trades, and as with the entry signal, the expert advisor creates the exit signal, assigns it to the expert object, and deletes the exit signal when finished. So in this installment, we're going to create indicator classes. The entry signal is most likely going to rely on some kind of technical indicator, and possibly more than one, and the same with the exit signal. So today we'll be creating a base class for indicators. And as with the signals, the expert advisor will create the indicator objects and assign those to the signal objects. So this makes a very flexible structure because we can mix and match indicators inside the signals and mix and match signals inside the expert object. And the final piece that we're missing is the trade handler, because the expert object at the moment has no way of actually executing trades and closing them. So we'll be creating the trade handler object, and this, because it's a pure utility class, I'm going to be creating it inside the expert object. It isn't being assigned from the expert advisor. And so this is the scope of today's work: the indicator classes and the trade handler, and of course how we can hook those into the expert advisor and the expert object. So let's now move on and begin with the indicator classes. This is the start of the IndicatorBase class. I've just inserted a comment so far. What I've done is create a folder, indicators, inside the framework 1.0 folder, and I've created the IndicatorBase.mqh file inside that. So first thing I need to do, I want to inherit from common base, as I do with most classes. And so then my class definition is class CIndicatorBase, inheriting public from C common base. And I'll just close out the class before I forget to do that. And next, I don't have any private member variables or private methods in this class, and I don't have any protected member variables at this stage, but I'll leave the placeholders there. Next, I have the constructors. So constructors are public. CIndicatorBase constructor with no arguments. This is the default constructor. Simply calls the common base default constructor to fill in the symbol and time frame, and then calls the init method, which we'll get to in a moment. Again, passing no arguments because there are no arguments being passed to the default constructor. And then, as usual, I've got another constructor that takes the symbol and time frame and then calls the common base constructor passing through that symbol and time frame, calling the init with no arguments. And then I have a destructor, and because I have nothing to do in the base class for a destructor, it's just got the 2 brackets. Close that out. And then just my init method, which also takes no arguments. And then I have some public methods that are intended to be overridden in the child classes that inherit from this base class. So first, there's the virtual returning a double because these are indicators and they're returning values which are typically doubles. The getData method, which simply takes an index, and that index would normally be something like the bar number for the information to be returned. And this particular getData function simply calls the next getData function, which we're about to describe, and it returns that getData, passing in the index and an additional argument, which is the buffer number. So maybe from other videos you remember things like the MACD has two different values. There is the MACD value and the signal value. A Bollinger Band has a high, a middle, and a lower value. So some indicators have multiple values. The default would be 0 because most indicators only have a single value. And so the simple method here, the simple getData, which only takes the index number as an argument, simply returns the next getData method passing in the 0 buffer number. And here it is, the virtual double getData takes a buffer number and the index number, and because this is the base class and there is nothing to do here, I'm simply returning 0. And the intent is, because these are virtual methods, that the child class that inherits from these will implement a getData method that returns an actual value. And then there is only one method that I need to write. It's this init method. So let me scroll down. And the init method, IndicatorBase init, it's simply checking to see if init result is not equal to init succeeded, and that will have been set by the parent of this class, which is just CommonBase. So if that constructor has failed initialization, then I'll simply return the init result, which is whatever is in this value. And if this test is passed, then I don't actually have any more to do here, so I'm simply returning init succeeded. I could have shortened this, but I'm leaving that space there so that if I come up with things to be initialized later, I can simply insert them here. And that's everything for the IndicatorBase class. I'll just do a quick compile on that to make sure that compiles. It does. And this is also fully compatible for MT5, so this same class will work for both MT4 and MT5 implementations. So now that we have an IndicatorBase class, I'll just create an all indicators include file. And remember, I had an all signals include file here into signals. I've created one for indicators as well, and it does much the same thing. It simply includes the base class, and then as I add more indicator child classes, I'll put include statements for those in here. That way this simple all indicators can be included in the framework, and every indicator then becomes available to expert advisors. Along with creating the all indicators file, then I need to update the framework include file. I'm just going to duplicate the signals line here. And now that IndicatorBase is already included in the framework. So the next step will be to update the SignalBase so that it uses those indicator classes. So now I have the SignalBase class open. The first thing I need to do is include the IndicatorBase file, and that way I can refer to the CIndicatorBase class within the SignalBase file. Next thing I'm going to do in here is to create a structure, and this structure will hold an instance of IndicatorBase and a buffer number, because all values I'm going to request from indicators would be for the given indicator and for a specific buffer. Now, most of the buffers are going to default to 0, but this allows me to have a single item or single variable of type SIndicator item that holds both the indicator and the buffer number. And I'll use this later and you'll see. Now, at some point in the future, I might move this structure and this enum out to a single file where they can be accessed by parts of the application that may not need to include the SignalBase class. But for now, this works, so I'm leaving these in here. They're also a little bit easier to read and understand, given that we're running a tutorial. So next, I'm just going to create a variable to hold indicators. I don't know how many indicators there will be, so using the SIndicator item structure, I'm creating an indicator list, and that's a dynamic array, so I can hold any number of indicators in here. And then, so that those indicators can be assigned by the expert advisor, I'm creating an add indicator method. So this method takes one variable of a type pointer to a SignalBase class and the buffer number, and the implementation of that will be down below. So now the implementation of the add indicator. The first thing I'll do in here is to initialize a variable of type SIndicatorItem. So I'm declaring the variable SIndicatorItem, and I'm pre-filling it with the values null and 0. It's probably not necessary to pre-fill this structure, but I'm going to do it anyway here. Then all I'm doing is assigning the indicator pointer to the indicator pointer value of the structure and the buffer number the same. Next, I'll take account of the number of indicators that have already been assigned, and then I make room for one more by simply doing an array resize to count +1. Now, if you've been reading the manuals, you'll see that there is an additional argument that can be passed to array resize to create extra space. Given that this assignment happens only at the beginning of the application, and I expect it to be called very few times, I'm not worried about the performance, so I'm simply increasing this by 1 to keep the indicator list array as small as possible. And then finally, I'm assigning the indicator item that's been created above into the last element of the indicator list. Now this will mean that if a particular signal requires indicators in a specific order, they will need to be assigned in that order by the expert advisor. And you'll see more of that when we get to next week's installment, where we actually create an expert advisor using this framework. And that completes the changes to the SignalBase. Let me compile that to make sure I don't have any errors. Good. And again, there is no difference here between the MQL4 and MQL5 implementation in this class. Now I'm going to update the EA template. So I've opened up the EA template 1.0, which we created here in the framework EA folder. If I go down to signals, previously I was able to create or set up variables for 2 specific signals. There was only going to be an entry signal and an exit signal. I'm going to do the same for indicators, but I don't know how many indicators there are. So all I'm really doing here in the template EA is create a placeholder, and I'm just calling it indicator 1, and it's of type SignalBase here in the declaration. Then inside the onInit section of the expert, I need to set up that indicator. And of course, if there are more indicators, I will set them all up here. And because this is just using the SignalBase, there are no arguments, no information to feed in. If this were a MACD, I would have a number of arguments to feed into that indicator. And so this will change depending on the indicator being used. Then, as I indicated in the introduction, I need to assign the indicators to the entry and exit signals. So here I'm just assigning this default placeholder indicator to the entry signal with the add indicator method that we've seen. I don't have a buffer number on this, obviously, so I'm assigning 0. And then I'll do the same thing for the exit signal. I'm using the same indicator here, again, because this is just a placeholder. Then most of the rest of the expert advisor doesn't change. I'm still just adding the entry signal and the exit signal, calling the onInit for the expert. In the onDinit, then I just have to remove the indicators that I've created. And obviously I'll be duplicating this line for as many indicators as I need. And that's all the changes required to the expert advisor template. I'll just quickly compile that to make sure I haven't made any errors. That works. Now I'm going to open up MQL5. Now I've just gone to the MQL5 editor to open the EA template for MQ5. The same changes, or the changes that I've made here to the MQ4 version, will be identical in the MQ5 version, but I've gone to the MQ5 editor because I can compile in here and know that it's completely compatible with MQ5. So let me just make the changes here quickly. So you can see I have added the indicator 1 definition there. I'm creating the indicator with SignalBase. assigning it to the entry signal and the exit signal, and I have the delete statement here, and if I compile that, no errors. So the same code so far, working for both MQL4 and MQL5. The last thing that I said we'd be doing today is creating the trade component. Now, MQL5 comes with quite a good trade object or ctrade class, and I want to model the MQL4 from that. But I also need to add in some methods that don't exist in that ctrade class. So I'm going to subclass from that. Now, because this is going to be largely based on the MQL5 trade class, that's where I'll begin, and I'll move on to the MQL4 after this. So firstly, I need to create the trade include files. I'm just going to create a folder inside my framework for trade. And inside here, I'm going to create a trade.mqh file. So this is the beginning of my trade.mqh file. I need this to be compatible between MQL4 and MQL5, but the implementations of trading in those two are quite different. I could include a lot of conditional statements here using if-def, but what I'm going to prefer to do instead is have a single set of conditionals here using the if-def MQL4 or MQL5, and then bring in separate files depending which version of MQL I'm using. So let me just create the include files here. So what I'm saying here is if the compiler variable MQL4 is set, then I'm going to include the trade_MQL4 file. And if the compiler variable MQL5 is set, then I'm going to include trade_MQL5. These are so different that at this stage there is very little that I can use between the two. So it's much easier to simply have two include files. But by having both of those called from this single trade.mqh file, everything else in the framework can simply call trade, or can simply include trade and get the appropriate version. So now I need to create this trade MQL5 file. So now here is the beginning of my trade MQL5 file, and as I said, I'm modeling this from the trade class that already exists inside MQL5. So first thing I'm going to do is include that, which gives me a lot of valuable trade functions. But then because this is incompatible with MQL4, and I'm trying to keep the rest of the framework so that it operates as one, what I'm going to do is subclass this trade file, or the ctrade class, as a trade custom class here, and that way I can use the trade custom class name for both the MQL5 file and the MQL4 file. So I'm now defining a class called ctrade custom, which inherits public from the ctrade class, which is defined here inside this trade.mqh file. At this stage in the framework, there really is only one thing that I'm missing from the existing ctrade class here, and that's the ability to close all positions for a single trade type, so to close all of the buy positions or all of the sell positions. The ctrade class includes a position close method, and there are two implementations of that, one that accepts a symbol name and one that accepts a ticket. The method that accepts a ticket will only close a single ticket, and if I have multiple trades open on that side, then I would have to call that repeatedly. And the implementation that takes a symbol name only closes one trade for that symbol and then exits. So again, that would need repeated calls. And neither of those methods accept an argument to indicate that I only want to close trades of a particular type, the buy or the sell. Now, this is being written from the perspective of a hedging implementation of MT5. MT5 can be hedging or non-hedging. In a non-hedging implementation, all the positions for a particular currency are netted together, so there effectively is only one position. But what I'm about to write should work because one position will be closed out just as easily as multiple positions. So to fill in the gap that there is no close by type, I'm just going to create a single method called position close by type. So this is the position close by type definition. It's a little long, runs off the screen. That's mainly because I'm using a large font so that it's easier to see. So position close by type, I'm passing in a symbol, which is the same as the position close implementation of ctrade. It accepts a symbol and also a deviation. I've simply added one more argument here, the position type, which is going to be a buy or sell. And then here is my implementation of close by type. And it's very similar to the MQL4 type methods where you might loop through and close everything for a particular type. So I'm simply setting my result to true, because this is a Boolean function and returns true if it's been successful. I'm counting the number of positions using positions total function, looping through, going backwards from the last to position number 0 using I minus minus. I'm assigning a ticket, which is a ulong type, using the position get ticket, and this takes a positional argument, so the ith value of positions, and I'm getting the ticket number for that. And then if I'm able to select the position by that ticket using the inbuilt position select by ticket method, passing in the ticket that I just retrieved, then I'm testing position get string for position symbol to see if that's the correct symbol as passed into the arguments here, and position get integer for the position type to check that that's correct type. And then I'm calling position close for the ticket and passing the deviation. And then if position select by ticket was unsuccessful, which it also would be if I've been unable to retrieve ticket, because this will be an invalid ticket number. So if that was unsuccessful, then I'm simply setting the return code to trade retcode reject, and that will be stored in mResult, which means it's available through that ctrade class later, setting the result to false and returning the result ultimately. Because this is in a loop, remember I'm setting result to true at the beginning here. Each time I call this position close method, I'm setting result using the ampersand equals. So this is effectively saying result equals result and the value returned from position close. So if this returns a false value at any time, result will become false and will remain false through the rest of the loop. I could exit at that point, but I'd rather continue to close as many positions as I can and then return the false value here, and that way the calling application has an opportunity to simply call this again to try to close anything that failed. And that's the only addition I need to make to the ctrade class, and I've done that through this ctrade custom class. Now back in the MQL4 editor, and I've already created a trade MQL4 file here in the same location as trade MQL5. So this trade file will now open the MQL4 if I'm compiling through the MQL4 compiler. Because MQL4 doesn't include a trade class already, I'm going to have to build everything that I need here. So I'm starting with including the common base file, because I'm going to be inheriting from common base. And because I've modeled this on the MQL5 implementation, I'm going to be calling this using the position enum values. Now they don't exist in MQL4, so I'm going to create an enum here of position type, with position type buy and sell being the same values as order type buy and order type sell. So next I create the ctrade custom class, close that out, and in this I need to have a magic number. The ctrade class of MQL5 already holds a magic number, so I need to create a place to hold the magic number in this ctrade custom class for MQL4. The constructors for this take no arguments, purely default constructors. Now to emulate some of the functions of the ctrade class, and I'm not even going to scratch the surface of the functions that are available there, I'm only building as much as I need. So first there's the ability to get the magic number back from this class with the request magic function, which is the same function name as in MQL5, and I'm just returning this internal variable. And of course then the set expert magic number, which again just sets the internal variable. I need two values to be available inside this class, the buy price and the sell price, because it's possible to call a buy or a sell method passing in a zero price, meaning take the current market price. So this will give the current market price depending whether I'm buying or selling. And you may have seen this before. For a buy, I'm simply getting the symbol value for ask, and for a sell I'm getting the bid. And two methods that I will be using from the MQL5 C trade class are buy and sell. So it implements this buy method and a sell method. I've added those in here to the MQL4 definition. They simply take a volume, which is number of lots, the symbol, a price, which you can see defaults to 0, and that's why I need these methods above to give me the current market price, and then a stop loss value, take profit value, and finally a trade comment. And then the one method that I had to create in MQL5, position close by type, taking the same arguments, symbol, position type, and slippage. The implementation of these in the default constructor, C trade custom constructor, I'm setting the magic number to 0. And at this stage, the deconstructor has nothing. The implementation of the buy method is fairly simple. If the price being passed in is a 0, then I'm reassigning price as the buy price for the symbol. And then I'm assigning a ticket number based on the order send function. So symbol, order type buy. So this is a market buy, volume, price, slippage, stop loss, take profit, comment, and magic number. And then I'm simply returning ticket is greater than 0, which will be a Boolean value indicating whether this has been successful or not. The sell implementation, very similar. If price passed in is 0, then I'm getting the sell price instead of the buy price. And when I call the order send method, I'm just passing in order type sell. And then the order close by type, or position close by type, this is very similar to any loop that you might have seen already in MQL4. I'm calculating a slippage. So you remember in the MQL5 implementation, the deviation was defaulting to U long max, which is an invalid value to pass in as the slippage. So all I'm doing here is saying that if I have received the U long max value, then I'm going to set slippage to 0. And if it's not U long max, then I'll set the deviation. Starting out with result being true again. In this case, count is orders total. I'm again counting backwards from count -1. As long as I is greater than or equal to 0, I minus. If I'm able to select that order by position from mode trades, if the symbol is the symbol passed in, if the order magic number is the member variable magic number, and if the order type is the position type, then result ampersand equals order close. And this is a standard order close method for MQL4. And in the end, I just return result. So the interface to this, as far as my expert's concerned and everything I need to use at the moment, is the same as it is for the MQL5 version. And let me just quickly compile that to make sure I haven't made any typing errors. I haven't. That's good. And now I need to update ExpertBase to use the new trade class. Let me get to ExpertBase here. Because I've added the trade class, I'm just going to put a reference to it here. I don't need to change the ExpertBase for the new indicators classes because they're all handled inside the signal classes. But the ExpertBase will interact directly with the trade classes. So now I need an instance of the trade class. I'll just put that here. And notice that I have declared this without the pointer. So by declaring an instance of ctrade custom, calling that trade without a pointer, it will create an instance or an object of type ctrade custom, but I don't need to call the destructor. And this will use the default constructor. So remember, I only had a default constructor for trade, so no arguments are being passed in. So this avoids the need to remove the object later because it will be automatically destroyed when this ExpertBase object terminates. It does lack some of the flexibility of creating pointer variables, but this works in the case of this ExpertBase. Now, the trade class is going to hold the magic number. I know I do have an internal variable here inside the ExpertBase class that holds the magic number, but it's also used inside the trade class, and that's because the implementation of ctrade in MQL5 stores the magic number internally in the trade class. So I'm going to replace this method with a method that also sets the value of the expert magic number inside the trade object. Now that's useful where this set magic method has been called, and that's the way that I've written the expert template. But remember that there's also a constructor that accepts a magic number. So here in the init method I had an assignment of magic number. I'm just going to remove that, and instead I'm going to replace it with a call to that set magic function, and that way it will both set the internal variable for magic number and also set the value inside the trade object. Now the next change, if we go down to the loop section, which is where we're processing the exit signals and the entry signals, this is where I previously had just a comment for close all. I'm going to replace that by calls to the new trade object to close the positions on each side. Let me put that in. So I'm using the position close by type method that we created, passing in the symbol and closing the buy or close and the sell in this case. And then if we've had an exit signal of buy only, I'm just going to take the buy line from here, and then I'm going to take the sell line and place that here. So this is using the new position close by type method. In the trade opening section, I also had just comments, open both sides here. Same thing, I'm going to call both that buy and that sell method that we created in the trade class. And then I'll just copy these. It goes in the buy section, so trade buy and trade sell in the sell section. And that is the extent of changes in the ExpertBase class. And this class is also still compatible between MQL4 and MQL5 because we handled all of the incompatibilities in the trade.mqh file here, where we called two different files depending whether we're MQL4 or MQL5. So let me just quickly compile to make sure I don't have any errors in here. That works. And if I go to my EA template file, I can compile that. As before though, the indicators are returning zeros, the signals are returning no trade. So if I were to run this now, I would still not get any trades happening, but this is a working framework, and in the next installment we'll create some implementations of that. I'll just go to the MQL5 compiler and compile that to make sure that everything I've done here is still compatible with MQL5. And in MQL5, yes, that also compiles. So that's the end of building the framework outline. In the next installment, we'll actually begin to create some real use of that. But just to recap where all of this fits, the expert advisor is responsible for creating and assembling all of the classes, the expert object, the entry and exit signals, and the indicators. The expert takes care of creation of the trade handler. The expert advisor is also responsible then for catching the events raised by the platform in the onInit, onDinit, onTick method, and passing those events through to the expert object. The expert object then does all of the main processing. It does the processing loop. It uses the entry signal that's been assigned and the exit signal that has been assigned to decide when to enter and exit trades, and then uses the trade handler to execute on those trades. The entry signals and the exit signals are responsible for the decision to trade or not to trade, but they will need values to make those decisions. And I've chosen not to embed the indicator values inside the entry and exit signals. I'm making the indicators their own class. This might be useful if you wanted to write an entry signal that could take either a MACD or a moving average or a Bollinger, for example. So in this way, the expert advisor can decide which indicator to fit into the entry signal. So entry signals and exit signals make the decision on trading. Indicators provide the values that support those decisions. And the expert object then executes on those trade decisions. So that's all I have for this week. Next week, as I said, we're creating the first working expert advisor using this framework, and we'll follow that up then by extending to include some additional features and showing how we can modify the framework. I have quite a lot of requests queued up already. If you have a request for something you'd like to see in this By Request series, use the contact form on our website or leave a comment here. I will put a link in the description here to show you where to find that comment form. If you're finding these useful, please leave a like. If you've got any further questions, leave a comment. And remember to click the subscribe and then click the bell icon to be notified if you want to see more of these videos. Until the next time, thank you for watching.